Good morning, everybody. Welcome to your maths for today. We're going to be comparing and ordering fractions less than 1 using what we did last week to help us. To begin with, though, have a go at this arithmetic start. Okay, let's reveal the answers. So for number 1, I probably wouldn't have known that cube number off the top of my head. So perhaps you did 11 times 11 and then you used the column method to do 121 times 11. Subtracting this one would have been a bit tricky. You'd have needed to include an extra placeholder here. Remember, factors are two numbers that multiply together to make a product. So factors would be two numbers that multiply together to make 24 there. Okay, and again, number 4, hopefully, you knew that 8 times 8 is 64, and then you would have added the zeros to make it 64,000. Right, so today, like I said, we're comparing and ordering our fractions. So if you look at this picture, we've got a half here and we've got 3/4 here. Can we compare them using these signs? We've got greater than and less than, okay? Well, looking straight away, it's easy for me to see that 3/4 is more than or greater than a half because it takes up its more of the whole. So I'd say 3/4 is more than a half or greater than, and 1/2 is less than 3/4. And again, there's lots of different ways, on the way that you use these signs. Some of you think of crocodiles, ice creams, whatever it is, as long as you know that the larger number goes at the larger end of the sign. Okay, so looking at pictures can help us. Bar model, also really useful. Again, if we look here, we've got use the bar model to compare 5/8 and 3/4. Let's start, which one is 5/8, which is 3/4. On this one, I've got my 5/8, 1, 2, 3, 4, 5, 6, 7, 8. This top one though, it looks like more than 3 parts are shaded. Let's investigate. Well, if I count just the green parts again, we've got 1, 2, 5, 6 out of 8 shaded. So that's actually showing 6/8. But if we look at the fraction, remember, equivalent fractions, let's just check, is 3/4 equal to 6/8? Well, if I wanted to turn 6 into A, I'd do divided by 2. Gosh, can't write there. Do the same to the bottom as the top. So that would be 8 divided by 2 would equal 4. Yeah, so this fraction, 6/8, is equivalent to 3/4. And it shows me that that is greater than 5/8. So again, we'd do 3/4 here. 3/4 is greater than 5/8. And then you could do it the other way around. Now, question. Should the bar models be the same size? I know earlier on last week, I mentioned, with the drawing, you can always use your squares in your book to help you. So if you were making quarters, 4 squares to make the whole. What's the problem with that, though? It's useful if we're just looking at one type of fraction. But if we're comparing, if you made something using 8 squares and quarters using 4 squares, your 8s is going to look bigger immediately, isn't it? So actually, when it comes to this, your bars need to be the same size, okay? Because each bar represents the whole. A whole cut into 8s and a whole cut into quarters, there shouldn't be there's no difference in size, is there? It's just the number of parts it's cut into. So pictures, bar models can be helpful. What about them? I've got 2/5 and 2/12. If I said to you, right, which one do you think is bigger? What might you say? What information might you use to help you with that? Well, if we remind ourselves, so we've got the numerator I can see is the same, but our denominator is different. Remind me, what does our denominator tell us? The denominator is how many equal parts something is cut into, isn't it? So if I've got, again, they're the same size. So let's just do a cheeky little bar here. I've got 2 holes. If I've got one that's cut into 5 parts and one that's cut into 12 parts, which one will have smaller parts? Hopefully you went, the 12s will, because again, I'm not going to be able to do this particularly equally. But if I had my 12ths, so that's 4, If I cut something into 12ths, I'm going to end up with pieces around this size. I know they're not exactly equal. I should have really used my ruler tool. So that would be into 12ths. If I've got fifths, I'm going to kind of go, okay, so 1, 2, 3, 4. Yeah, roughly. And if we shade those little fellas in, I got 2 12ths here and I got 2 fifths here. So we know that the bigger the denominator, the smaller the fraction. It's one of those opposites, because the more parts you cut something into, the smaller they're going to be. The bigger the denominator, the smaller the fraction. Therefore, if we look here, straight away, if my numerator is the same, I'm just going to compare my denominators. Fifths are bigger, greater than 12ths. Okay, and we can see that with my example. One other thing you could use to help you, if you remember, we had our fraction walls that we looked at a couple of weeks ago. I'll see if I can remember to put them up for Monday's lesson, today's lesson as well. But yeah, you can literally look, can't you? If you've got 2 of something, just check, what does 2 fifths look like? What does 2 12ths look like? All right, so same numerator, different denominator. We can just compare those denominators, and we know the greater the denominator, the smaller the fraction. Right, now this time we've got another added layer. It's a little bit trickier because we've got different denominators and different numerators. Okay, but again, if we look, I've done a bar model to represent it. I can see that 4 fifths is going to be more than 2 sevenths. There's a couple of reasons. I know that fifths are going to be larger than sevenths because it's less parts it's cut into. And if I've got more fifths than sevenths anyway as well, that only confirms further that actually 4 fifths will be more than 2 sevenths. Yeah? So I can use, I've used both bits of knowledge there. I've used looking at my denominators, knowing that the bigger the denominator, the smaller the fraction. And then if I've got less of them, if my numerator's less as well, then that confirms it for me. So why don't you guys have a go at comparing these fractions down here using this method? I would suggest either drawing yourself out some bars, make sure they're the same size, drawing yourself out a pizza to cut up, and compare them either by shading or by looking at the denominator first and then the numerator. Okay, why don't you pause me and have a go? Right, 2 sevenths is going to be less than 4 eighths. Although the denominator is bigger, we've got less of those parts. Maybe you drew that to confirm. 1/3 is going to be less than 5 tenths. I know 5 tenths is equivalent to a half, so a half is always going to be bigger than a third. 6 elevenths and 3 fifths. Oh, let's have a think here. I believe, yeah, 3 fifths is going to be just slightly larger there. Okay, but maybe you drew that out to check. Right, okay, so as was the case with last week, we've had a couple of practical ways to look at it, and now I'm going to show you kind of the mental maths way of doing it. So if I've got 3 fifths and a half, I can do something called finding the common denominator to help compare and order. Now, a common denominator is exactly what it sounds like. Common denominator is just finding a denominator that is the same for both of them. Okay, now we have a look. There's a couple of steps in doing this. If I've got 3 fifths and halves, now looking, I'm not going to be able to turn either of them into the other. So I can't turn halves into fifths because 5 is an odd number. It won't be in my 2 times table. And I can't divide 5 to turn it into 2. Okay, so instead, what I'm going to do is I'm going to think about my multiples of those numbers. So numbers in the times tables, so of my denominators. So I've got my 5 times tables and my 2 times tables. There we go. And what I'm looking for is the lowest, the smallest number in both of their times tables. Now, if we look, we can see 10 is the lowest number on both of those lists. Yeah, can we see that? So in which case 10 is going to be my common denominator. I'm going to turn both of them into tenths. So if we start with fifths and I want to turn them into tenths, what am I going to do? I'm going to multiply because it's getting bigger. 5 times 2 is going to be 10. And then I do the same to the bottom as the top. So 3 times 2 would be what? It's going to be 6, you legends. Have a go at 1/2 for me. Can you turn that into tenths? Pause me, then come and check your answer with mine. Right, I'd multiply the bottom by 5, do the same to the bottom as the top. So it's going to be 5 tenths. Okay, now they're both in tenths. It's really quick to see straight away, isn't it? That 6 tenths is more than 5 tenths. So 3/5 is going to be bigger than 1/2. Yeah, easy peasy. So if you've got different denominators and different numerators, you find a common denominator and then you can compare them. All right, let's have a look at another couple of examples of this. Sorry, let me give you an example of those. Right, okay, so say I had 1/4 and 3/8. Can you compare those two by finding a common denominator? Pause me, come back. Right, I would have turned 1/4 into 8. 1/4 is the same as 2/8. So I know that that's going to be less than 3/8. Because I can just compare the numerators. So therefore 1/4 is less than 3/8. All right, everybody. So what I'd like you to do for me is I've just done another tiny little video just to show you a little bit on. So we've done some comparing. I wanted to just spend a little bit of time looking at ordering fractions separately. So join me for just a short little snippet on the next video where I will also give you your fluency for the day. All right. Have a lovely one, guys. Bye-bye.